Okay, so my name's John. I'm a technical trainer, sort of as my side gig. By day, I work as on the Amex iPhone app. And this is my site. I am currently writing a book. If you are in iOS or you know somebody who is, there are not a lot of mobile developers, I don't think, at this conference, but you know somebody who is. Send this to them. It'll help them a lot. The book isn't finished yet, but you can get what is out there, which is mostly done. I want to start back with this. Who knows what? Yeah. Okay, so I want to tell a short story, and at some point, your story is going to enter the story, and we'll figure out where that is. For me, my story with coding started back in junior high school when the high school teacher was teaching Fortran, and we had, honest to God, punch cards in the Math Resource Center. They're really loud things. I still remember, and the keys are like ka-chunk, ka-chunk, ka-chunk. So the teacher let me sort of, sneak in, as it were, and submit programs. The way it worked was you would write up your code. You can't write up your code on this thing. You have to have it written. Otherwise, what are you typing from? So you write up your code, longhand. I think I remember there were forms. Yeah. And then you sit down at the punch cards. So you might make a mistake first in the original source. You might make a mistake when you sit down and you actually type it out. And then you end up, for those of you who don't have experience with punch cards, who has experience with punch cards? Oh my gosh, you're kidding. This is an old conference. For those of you who don't have experience, this is basically one line of code. Okay, so you add up all your lines of code and you end up with a little deck, and you submit your deck. And for us, we submitted our decks on Friday, and then the teacher or somebody would take them to downtown Tokyo, because we were on the outskirts in the suburbs, the boonies of Tokyo, take it to downtown Tokyo, to NCR, which generously donated time over the weekends to run our short little jobs. And each job would result in a printout. That's your output. And from that output, then, it would come back on Monday. So if you think about my feedback loop, if I have an error somewhere in the process, then I won't know for days what went wrong, and then I'll start it all over again. Life got a lot better when I sat down at a VT100, right? And those green glowy CRTs, because the feedback got a lot faster. For one thing, the way it worked is, how many of you, have done like a CRT coding? Yeah, okay, so a few more of you. For those of you who haven't, well, it's just like you've seen in the movies, except we're not typing that fast. You would edit your code in an editor. It knows nothing about code. It's just like characters. That's all it is. It's just a character editor. And then you would save it, and then you would go, and then you're back in your terminal session, and then you compile with one command, and you might have some problems there, and that's okay. That's better feedback already. And then you link, and then you might get some feedback from there. And then you have an executable, and you run your executable, and you have your feedback from there. So that's getting better. That's better. Now we come into the near modern world of the old IDEs, where you didn't have to do all those steps. They sort of did it for you, right? And this is in the early days, before they did any sort of styling. Who remembers IDEs without styled text? Yeah. So, you'd type your code, and then you'd say, basically, build and execute. And at least that became one step. So we're getting better, we're getting faster. And then the IDEs became smarter, right? And now they know something about the language, so they can show you the syntax through highlighting. And then they got better still, where they know not just about sort of syntax, they also do some sort of pre-compiling trick, where you can see, even before you're like, I haven't built yet, but it's already showing me, squiggle mark. The feedback is getting better and better for me over the course of my life. Now, all the feedback, though, that I've been describing has been about the language, the syntax. And if you add a linter, it might be about idioms, about the language, but not about your domain. I want you to imagine a magical compiler that understands not only your programming language, but also your domain, the stuff you're working with, the thing you're trying to get to work. If you had such a compiler, then it could just say red or green, and that feedback. See, what happened when I was working with punch cards is making a mistake was terrifying because the feedback loop was so long. There was a lot of cost. As that feedback loop has grown shorter and shorter and shorter, I can be a little more wild and hacky even, and just look, let's try and see. Now imagine you could do that with your business rules, and it would check whether or not the thing worked as far as it could tell. That is what we get with a good solid suite of unit tests. Now, where do those come from? They don't come from, we don't pluck them out of the air. We have to do the work of instruction. We have to do the work of coding to teach the compiler plus testing system what the rules are. And that takes some work, and that's something worthwhile, worth learning, and is certainly part of test-driven development. But that's sort of my goal. I want something where I can just say, blah, 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 and it tells me, red or green. The problem is, anyone tried to add tests to code and find it really frustrating? Sometimes it can be really hard. Does anyone know where this is? This is right here in San Jose. This is the Winchester Mystery House, for those of you who are a little further out. These are the stairs that go nowhere. This is kind of what it feels like to me, to add tests to code that is already written, is that the stairs already go up to the ceiling. It's like, oh, great. Where do I put my tests? Well, it wasn't written with that in mind, and that's the problem with a lot of code where testability is not a first-class requirement. So, what if we flip it on its head? What if we say, well, let's not do this then? That would be the easiest sort of path. It's still hard, trust me, because learning how to write those tests and how to structure the code to be testable, there's a lot to learn there. But if you can do this, and especially if you start with something simple, like just business rules, I've got these inputs and I expect these outputs, you can start to do this right away, right? So let's flip it on its head. The basic steps of TDD are 3 steps over and over like a waltz. And I want to dig into them. You probably already know a little bit about what they are, but there's some subtleties. There's some brilliant subtleties about how these work. The first step is to write a failing test. Note that it does not say write a suite of failing tests. That doesn't mean you can't design a sort of a suite of failing tests, essentially sketch them out, write them out, but it means you don't code them all. You start coding one, just one. There's a strong theme in TDD, and that is to try to limit the amount of things you're changing at one time. So that if you have any trouble, the quickest way to get back to a safe place is to revert. This has become a theme of my life, is to try to do one thing. All right, so we write a failing test, just one. Then we get it to pass. There's more here that I'll explain later, but an interesting thing is that you can get the code to pass in any hacky way you want to, because there's a third step. We're so trained, and I see this when I teach my colleagues at Amex. I'm like, okay, so now we got the failing test. Now get it to pass, and they're trying to do the most like, wow, we can use a filter or a map, and they're using high-level functions that deal with functions that are passed in, and I'm like, no, just get it to pass. Anyway, the critical thing is to try to do it quickly. If you can write filter and reduce and do it quickly, good for you. I'm not there yet. I write it out. I write out loops and stuff, and then I'll clean it up, because there's this third step, which is to clean up stuff. And the cleaning up is of production code. It is also of the test code. This is a subtlety that I had to learn over the years, is that you're writing code. You're now writing twice as much code. And code is code, and code can be messy. Actually, code becomes messy unless you exert care. And so refactor both sides, and we repeat. Any questions so far?
Okay, I need an example, because in my mind, writing failing tests is you're checking your test algorithm so it doesn't crash the system. In your case, it's obviously different.
Right. We'll get to a little example, but it's not just that something doesn't crash. It's that it actually performs something useful. Something useful that it didn't do before. We'll do a really trivial example soon. Any other questions about the 3 steps? Let me describe them a little further. What if I say the first step is to make something automatically verifiable? Unit tests are executable specifications. This is the sort of the brilliance about having a good set of tests. You can also have bad tests, and that's like a different talk, right? But a good set of unit tests are executable specifications. You're making something verifiable. And then you make it work. First, you make it verifiable, then you make it work, then you make it right. Separating make it work from make it right is kind of like, this is something I feel right now as I write my book, that there are 2 halves of the brain for writing. There's the author side and the editor side, and I have to be able to flip them around, because the author just wants to spew out words. And then the editor comes in and says, and it really requires you to turn on a different part of your brain to do this, to analyze critically and say, well, it works, but how can we clean it up now? Now, one thing I've found, let me put some more labels on this. Step 1 is to test. Step 2 is to code. Step 3 is to design. This is one of the challenges, I think, is that if you've done code for any amount of time, this looks backwards. Don't you design first, and then code, and then test? And I have a rough idea that came to me the other day at work after teaching an exercise with 2 different groups of people. And that was, I'll have to try this some more to see if it holds out. But I have a rough theory that the more experience you have with coding, the harder it is to learn TDD, because you already know how to get stuff done. You've been doing it for a while. And so me then coming out and saying, okay, well, now I want you to put your head on backwards, it's just like, ugh, and you're going to fight me. Whereas beginners are kind of like, well, sure, he says to write a test. So I guess I want to share that with you as encouragement that if you find this hard, that means you're really good at what you do, and press through that cognitive dissonance you feel about this feels wrong, or this feels backward or awkward. That's part of learning. I want to get into this transition some more. From red to green. This is very critical. If you think of it as we have a light bulb that is the result of the test. And the switch is making a change in production code. Okay, I want you to do a thing. Everyone hold up your light bulb. That would be like this hand over here or whatever. And pull the switch. Whoop. Put it back. Whoop. Again. Whoop. Whoop. Now, what did we just prove?
I won't do anything you say.
Everybody go like this.
Works on my hand.
It works on my hand. Oh boy. No, what did we show about the test code and the production code? One side is the test, and the other side is the production code. We make a change in the production code, and a thing changes in the test. What does that show?
Connected.
They're connected. They're actually talking to each other. One of the challenges I think that programmers have when I say, okay, so write tests for your code, and they'll say, oh yeah, well, tests are code too, wise guy. So how do you test that? This is how you test that. You test it not by writing tests for your tests, although, well, that's another topic. You test it through this discipline. You test it through this process of first seeing it fail. If you have a unit test that you've never seen fail, does it work? Do you know? Watching it change from red to green is critical. So it proves that they're connected. All right. Now, so that's the 3 steps of TDD. That's enough to get you started. But I also want to show you something that I've really taken to heart lately, and that is the 3 laws of TDD. And this is sort of down one more level from the 3 steps. It's a lot of words that I can explain more simply. Here's law number 1. You are not allowed to write any production code unless it is to make a failing unit test pass. Well, for TDD, that sounds reasonable. You know, if you do TDD, you kind of expect that you don't get to write production code first. But law number 2 says you are not allowed to write any more of a unit test than is sufficient to fail, and compilation failures are also failures. What? I'll show you what this looks like. But basically, to say, I want to write a test now. Okay, law number 1 prevents me from just writing the production code, so okay, we'll go write the test code. Law number 2 says you can't just go wild and write a whole bunch of test code. That we want to move in small steps. And the same thing holds true for law number 3. You are not allowed to write any more production code than is sufficient to pass the one failing unit test. What this means is that once you have a failing test, well, now same thing applies. You don't get to go wild in the production code and say, wow, now blah, 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 blah. So it's really weird, and I'm tying one hand behind your back. Okay, I want you to do something else, something physical for me again. If you're able, could you stand? If you do not wish to stand, you can use your arms to simulate our legs. Because this is going to, I've got the walking person over here. Okay, we got 2 legs. Or 2 arms. Production code, test code. I want you to pick up 1 leg. Woo, you're changing that. You're changing the test code. Now put it down. Now we can change the production code and put it down. Test code, production code. Whoa, don't fall. I am not liable. Test code, production code. Go ahead, have a seat. Olympic walking has always looked really silly to me, but one of the critical rules is they are not, something has to be on the ground at all times, or otherwise an Olympic walker is like disqualified. You cannot go like this because it's dangerous. Here's how we do most coding. Production code. Woohoo! And then maybe I put down a test. And then you say, okay, John's taught us how to do TDD, and so we're going to do sort of production code and test code at the same time. And that's okay to get started with. And that is how I did TDD for a long time, was changing both at the same time. But no, it is about safety. It is about the ability to take 1 step, and if there is a problem, revert that 1 step. And the world hasn't come crashing down. It's kind of abstract, so let's make it concrete. FizzBuzz, you're probably familiar. I shouldn't say you're probably familiar. Some of you are familiar with FizzBuzz. It is a counting game that is often used as a little programming exercise. It's surprisingly useful in a screening interview, I have found. You may think it is too dumb to be a screening interview exercise. I've learned things about candidates. I've also learned different ways of doing FizzBuzz. Anyway, the rules are to create a function that takes a positive integer argument, and if it's a multiple of 3, it returns fizz. If it's a multiple of 5, it returns buzz. If it's a multiple of both 3 and 5, you're supposed to say FizzBuzz. This is a child's counting game. And otherwise, you just return the number, but it's got to be in string form. So if we were doing this, if you were 1, and you were the function, and I gave you 1, you would answer 1. This is how the game works. And then 2, 2. But I go to 3, fizz. And 4, 5, buzz. Right? So, and so it's like a little multiplication game. Take a couple minutes. If you've got something to write with, I want you to sort of write down the test cases to flesh out this game. Because there's nothing wrong with writing them down on something else that's not code. Think about, so this is not like generating 100 such results. It's just taking 1 input and returning 1 output. What are the inputs you need? Think about it for just a minute. Write them down if you can. Everyone growing a list, at least in your head, of the kinds of inputs you want? Let's do it. Normally when I teach workshops or we use mob programming. We're not going to do that because it's too big. We don't have enough time. We're not even going to finish FizzBuzz, I'll tell you that. We're barely going to get started on it. But, but since this is a group coding exercise, a couple ground rules. One is that this is a no-shame zone. You may be an experienced programmer, but have zero experience with unit testing. You are welcome here. You may be a new programmer. Maybe you come from the testing side of things. You're like an expert tester, and you have zero coding experience. You are welcome here. You may be new to both. You are welcome here. There is no shame. The other thing is that I'm going to ask for your input. I'm essentially going to be the typist, and I'm going to do it in Swift because that's what I work in. So you can call out what I should do in sort of a, meta programming. It's English, and tell me what to do. I'll translate it into Swift. But I do ask that folks of privilege yield to the less privileged voices. What I mean by that is if you're used to just speaking out in one of these things, you've been doing it ever since you're in school, I'm going to be the first to the answer. Take 2 breaths to give someone else who doesn't normally operate that way a chance, okay? FizzBuzz. Here we go. I have a blank thing. It's got nothing in here except some scaffolding. Let's start. Where do I start? What's the first thing I should begin to start? Write a failing test. To do that, I'm going to create a home for them. And put it in the test target. And I like to start with the trick I call test 0. And that's just to see if I've got the thing hooked up right. Because sometimes it doesn't work. And I'm like, oh, shoot, I put it in the wrong place. Okay, let's get rid of test 0. I am ready. Tell me what to type. Tell me what direction to go, and I'll figure out what to type. Minimum, maximum. So this is a common thing, is that as coders, we like to think about ranges and complex inputs. What I want you to do is to provide not rules as if we were in an algorithm. Instead, I want you to provide a single concrete example. This might have been called example-driven. In fact, unit tests might have been best called like examples, maybe.
So what are you testing?
What are we testing?
We need a function like FizzBuzz.
We need a function that's going to take some input. What input?
1.
1. Let's start with 1. Whoops. Okay, so 1 should, I'll just say 1 should 1. It's kind of a funny test name. Now, I want to talk to a thing. We could do FizzBuzz with a free function, but most of the time at work, we're working with much more complex things than FizzBuzz that have to live inside of classes. So let's put it in a class to pretend that it's more complex. What shall I call it? FizzBuzz. Most Swift programmers are telling me right now to let some variable name, and I'm like, no. Let's just do that. Boop, I've got red, and now the second law of TDD says I should stop. That is enough. That is enough for me now to switch to production code, because I want to get that red away. So I'll make a FizzBuzz thing. I'll put it over here. And that should do it. Eventually the red should disappear when it catches up with me. Maybe if I give it a little kick. Right. And it has no arguments because this is a super simple case, but most of the time stuff like has arguments, so it's like gets really long. So I prefer to put it in a variable instead of just starting to call this new thing directly. So let's say, what do I call it? What's that? This is not the result of calling it. This is the instance of the object. So FizzBuzz or game or, well, I'll just call it FizzBuzz. Sure. Okay. Now we're ready to call the thing. So I can say FizzBuzz dot function name or method name. What's that? Input. Input. FizzBuzz input. Run, evaluate, play. Yeah. Input is I think the reason I hummed away from it is that it can apply to so many different things, and the closer it is to the domain, the better. Part of TDD, I told a little lie, which was that the design comes at the end. Here we're actually doing some design at the beginning, which is we're designing the API. The test is the first client of your code. We're designing our internal API, as it were. So, string, what? Calculate, play. Calculate. I'm going to go with calculate just for now. And 1. Now, I've got red, but I want to give my idea a little more context by saying what is the actual result type. It is going to be a string. So that I can then say, and now I stop, right? Now I've got red. I've fleshed it out so that I have a full definition. I can now create from this the interface and say go. Argument number, integer, string. We don't want a fatal error. We need to, it returns a string. I can't have it do nothing. So what shall I return? Let's try empty string. Let me space it out there for you. And that should go away. Okay. Now I'm ready for the assertion. What do I say? What does assert mean? Right. So in a unit test, the assertion is the thing that you're saying must be true, and if it's not true, the test will fail. That's how the thing works. So there are several. The easiest is to say equal, where result is 1. Great. I think we finally got, so we did a little bit of this, right? That was the 3 laws in action, was to say, let's go here, let's go there, back to test code, back to production code. moving in small steps to grow the test gradually and essentially grow a little bit of infrastructure. Just enough to see it fail. We want this to fail. If you're new to TDD, it sounds weird because it's like tests shouldn't fail, they should pass. But remember, we want to see you want to see it fail and then become green. So now we made it to the first step. Red, write a single failing test. Yay! Good job. Okay, yes?
What's the XCT for? So that's all.
Oh, it's Xcode. It's Apple's testing framework. So I'm working within an Apple environment, and it uses XCTest is the name of the testing framework.
Okay.
That's all.
And so you're indicating you're calling that?
Yeah.
Okay.
Yeah. Thank you. Yeah. Someday maybe we'll have some real better tests. Anyway, okay, so it fails. It fails the way we would like it to fail. Let's get it to pass. What do? Try to get there quickly.
Put the number 1 in there, in the return statement.
But that's cheating. Every programmer out there wants to start out by saying, let me convert the it's like, nope. You get a literal. And we expect this to pass, and it does. Yay! And then we refactor. This is brand new code, so there's really nothing much to refactor here. There is, oddly enough, one little thing I want to refactor here, and this is a Swift thing, where I don't have to just say the type anymore. I can let it infer the type by removing that.
Why are you making that change?
Swift people don't want to have that all over the place. It's just a culture.
So it makes it easier for you to replace or change the interface to calculate.
No, it's just ornery. It's part of Swift culture to try to omit types except when necessary. A common thing, even though we pay a price for it in compile time. Okay, so we come here. Now, what do you think of this? How are we doing on FizzBuzz? Is this wrong?
It doesn't really do what the original thing asked, right?
That is true. It does not do what the original thing asked. But is it wrong?
No.
It plays the first round correctly, right? And that's cool. That's good. This is also one of the battles I think that coders face is you want everything to be complete. And this is incomplete. This is correct but incomplete. And what that feeling, that tension you're feeling right now is telling you is there is more to do, that there is more tests to write. That feeling tells me I need to write another test. So let's do that. What's my next test?
3.
Oh, battle between 3 and 2. And there's an art to choosing the next test. And, either could work. And we'd get there eventually. Right? Eventually, we'd get to our full set of tests. But the order can have an influence because right now we have this hard-coded 1. And it's like, I really want to just convert number to a string. Well, what's going to ask me to do that? A test is going to ask me to do that. So let's make a test that asks me by providing 2. Okay. Pass or fail? I expect this to fail, call the shot. This is a technique in TDD because sometimes there are surprises. You say, I expect this to fail, and it doesn't fail. Well, that's something to learn from then. That's telling you either the test is wrong or the production code already does the thing. And either surprise is instructive. All right, run tests, expect red. Yay, it's red. So now I can do the thing of saying convert number using string interpolation. And now we're green. So now we actually play most of FizzBuzz. And this is all we're going to get to do on FizzBuzz. I'm sorry, we're not even going to fizz once. But you can try it as an exercise. If you haven't done TDD, give it a go in the language of your choice. You know, before I go on, there's nothing to refactor here. But I look at this, and because of how XUnit style testing frameworks go, that's the style that XCTest uses. I see code duplication here. Do you? Yep. Yeah. The call to calculate, that's okay, and the assertions are different, but that first line is the same. If only we could extract that, and we can, by pulling it out into, let me just copy and paste that. Say this is, and I'm not going to explain Swift syntax here, what that does there, but I'm going to make a setup. So now I'm making a property that's available across all the tests. And I also like to cheat here and say, just generate my teardown for me. Thank you. And now I should be able to delete this first line and run tests. Good. And delete this other first line and run tests. Good. So a little bit of cleanup, which will help other tests go well. Yes?
Why?
Why?
Why make that, why do that refactor? Why bother with this separate setup?
In this case, maybe not a lot of gain. In real life, most of the time we're making more complicated objects that have lots of arguments where it's like, I need to set up all these things. Now, it doesn't necessarily belong in setup. Setup is only for stuff that's the same across the tests. And if you have, if you need to vary the inputs, the initial arguments, then don't use setup. Instead, make a helper function saying, make FizzBuzz, where it's like, you know most of the arguments to use, but let this test specify this other thing, so that each test can vary sort of the one thing. So that's my rule of thumb. Some people don't like setup at all and just say, just use helper functions. That's fine. And like I said, it becomes more important as the construction of the thing that you're trying to test becomes longer. FizzBuzz is trivial.
The advantage of helper functions is you can look at the test without having to look at the setup and fully understand the test.
Yeah, so the advantage of not using setup is that you can just look straight at the thing, and there are people who prefer not to use setup. I kind of like it. Use whatever style you like. Let's get back to, that's enough. That's all the time we have for code. What struck you? This was like a really brief demo, super brief. Anything strike you? What did you observe?
You're missed negative cases,
Missed negative cases.
right? Stuff out of bounds, out of the domain. Let's say they put something non-numeric.
And in that case, then it's a question of, does that belong? It's the question of, has it been pre-sanitized? Like, where's the API boundary? The question I should repeat for the camera is, what about like bad inputs? Shouldn't we test those? What if you pass in a negative number, which I kind of said don't do? And that's really a question of design. Like, what should happen at that point? Should it, throw some sort of exception, or maybe you say, I'm going to trust that it's all good, or maybe you put in what you call that?
Try again. Sorry, bad input.
So that would be, if you want to say, please try again, bad input, then that would be something to go take back to the requirements, the product owner, whoever you're working with, to say, what should happen? And based on that conversation, then write some more tests. Sometimes I'll put in preconditions. That's what it is. Where it's like, it should just crash. We should just hard stop. I usually don't unit test those, although there are tricks I've found to say, to work around some of those things. But most of the time, I'm just going to assume the inputs are good. Yes?
I don't know if it's what you're asking, but what struck me is that it took a lot longer to do what you demonstrated rather than just writing FizzBuzz to begin with.
True. So the observation is that it took longer to do all that than to just sort of code up FizzBuzz. Yep.
You ended up with a test program as part of the work you completed.
Yes. So as part of the basically the artifacts produced by this process, we end up with not only FizzBuzz, we end up with a test suite.
Not only a test suite, but documentation of your API.
Not only a test suite, but documentation of the API. In fact, when I'm reviewing code, I kind of like to see the unit tests first, because they give me a clue about what is this thing, because you get to see the caller, not the guts. You get to see one of the callers first. All right, I'm starting to run out of time. Here's a question. What's stopping you? There are a couple types of barriers that you will face if you want to do TDD. Some of these are technical barriers. Some of these can sometimes be management barriers. What sorts of barriers do you imagine you might face if you were to do this? What's stopping you from doing it today?
Takes longer.
Takes longer. Is that, I'm going to put that as a management barrier. What else? What's stopping you?
A lot of times, especially when you are a programmer in a non-software company, like I work for a manufacturing company, you cannot get management to understand like what a requirement is or anything. Like, I mean, it's sort of, it's the old, we need a rock. Okay, here's a rock. Well, now we need it to look like this, and so you're constantly kind of coding to guess what they want.
Oh.
Really having a requirement and understanding, you don't even know how this works,
So it can be a challenge to actually get requirements to work with. And so how do we do that without tests then? We just, if we don't have firm requirements, I guess normally you just sort of hack something up and show them and say, is this what you want? Which is valid, right? Although probably coding is not the way to get that feedback. Drawing stuff would probably be the faster way, right, to get that feedback. The tests sort of force you to say, what should it do? And that's a valuable conversation to have. Any technical barriers?
Sometimes if you're doing like data science work where you're trying to compute certain things, in real world your data sets might be pretty large that you need to use as an input to compute.
Okay.
But that might take a lot much longer to run a test.
Repeat the question.
So the suggestion, and I'm typing it up, is that large data sets may mean slow or super complicated testing. Any other barriers you think you'll face if you were to turn around on Monday?
Lack of tools.
Lack of tools. I'm going to put that down as technical. What else?
Legacy code, something that you've got to maintain.
Oh.
In a monolithic block.
Legacy code. Yes?
About asynchronous events.
Async. Asynchronous events. So this is essentially becomes, how do I even test this thing? And learning how to do that is important, right? Otherwise you'll be stuck. Or sometimes what I've done before learning how to really work with asynchronous events is to say, oh, well, I'm not going to test that part. Let's assume a bunch of stuff happened, and I just want to talk to this one thing in the middle. And let's skip all that other stuff that I don't know how to test yet. That's totally valid. Start from an easy place. This is advice that I'll give to you. Is start easy. Start with something that has input and output and nothing else. And you may have trouble finding such a place. Try to make such a place. Yes?
Not all parts of the code can be tested. Like, let's say service calls.
Service calls, yeah.
We're trying mock or something. And putting the app in different modes, like offline.
So anything that's dealing with like external dependencies gets hairy because it's like, oh, you don't actually want to make a network call. Then you have to learn how to do that. The way I approach this, again, it's like stop, get as far as you can and stop. In mobile land, most of what I do is making calls to web services. And the way I write those tests is not by making a call. It's by making a thing that represents the request. So that I can say, okay, make the request. Now stop. And then the test says, okay, now let me poke around. Does it have the right URL? Does it have the right payload? And I can check all of those things without going end to end. Great. I'm going to put these up. Yes?
You work not alone, but with other people.
You work not alone, but with other people. And so what problem do you face as a result of that?
So basically, you don't share the same knowledge about it. People have different knowledge about the task.
So
It's an iterative process.
I'll share one problem I certainly faced when I've done most of my TDD alone, and it was before CI. So one of the problems I faced was I would like get something all wonderfully tested, but my colleague would then see not the test, but the resulting code and see that I've exposed some things in order to make it testable, and the person was like, well, that's dumb. You shouldn't have to do that. Just inline, blah, 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 and get rid of this and make it private. And I'm like, oh no, you just broke my test. And they're like, your tests are stupid. So culture, sharing knowledge, and I think I don't know what to call that, sort of group buy-in. But you don't need group buy-in to get started, not totally. We are zipping through time. Let me mention, okay, so let me talk about time. This is one of the biggest things about sort of the negative feedback about TDD is it takes too long. It's like what takes too long to do what? We need to be more precise. Because here's my favorite study on this from Microsoft and IBM, who are no slouches in producing software, is when they found by testing 4 groups, having them do TDD, that the defect density decreased 40 to 90%. It's huge. I think probably they're measuring defect density like in problems per character or maybe problems per line. So this is huge. Now, there's a price to pay. The price is, well, you're writing more code. So that takes more time. There's a 15 to 30%, 35% increase in initial development time. Here's the problem. Your customer does not care about initial development time. Only your boss does. And so we need to shift away from that because that time is made up. If you think about how long like a JIRA ticket takes to go through all the way and how many people and how many meetings and so forth, just skip all that. So we need to get away from this mentality that our job is to lob code over to QA and say, I'm done. And that's mainly because of the pressure from, I think, managers who don't know any better. Ron can teach us how to manage. To say, are you done? Rather than think of it holistically as how soon can we ship? That's the real question. And in my experience, it does not impact ship time. Not even on the first round. You can imagine how this will save time down the road. But even on the first time, I come out even. Now that may be because I'm experienced, and when you're starting with TDD, it may take longer. And so to give yourself grace, first, where do you, let me just put up this corny slide. I bless you, I give you permission. Say, John says it's okay. To get started, don't start in production code. Start with exercises. This is a good exercise because the tests are already written for you. They're all disabled. We turn them on one by one. And eventually you'll get to learn how emergent design works, how TDD works, where the first step is done for you. I'll have all these slides up for you. There are plenty of exercises from the bowling game where you score bowling to convert Roman numerals. Lots more exercises at Coding Dojo. In order to get work done, you're going to need, to prevent that situation I described where you write a test and then your colleague comes along and plows through it and nobody's any the wiser, you're going to need a build system that's actually reporting failures. So that might be something to learn from. When it comes to difficulties with side effects, like how do I deal with a service? For that, you go talk to Ted Young, who will teach you how to do hexagonal architecture to design it so that all those things are on the outside. And you can just write unit tests against your core. And another thing I've learned is that if your local build time is too long, then the feedback loop problem comes back. Your CI still has to build your whole thing, but maybe you don't have to. Maybe if you break things apart into modules, you can write a little, you can get that feedback faster. So that's some advice for when you actually start working in your production code. Legacy code. Get the book. It's old, it's still good. And I am out of time. Let me skip to my last.
That book's more than good, it's awesome.
It is awesome. Go here. Get this. For a couple reasons. First, I'll have the slides up, including the changes that we made. But also, it's got links to giving feedback for CodeCamp. I also would like your feedback. I would also like you to figure out what your next step is coming out of this. Your next step may be, I need to learn more and do some exercises. Good. Do it. I'd like to know about it. Your next step may be, I need to clean out junk tests out of because our build system is just like, there are tests that fail, and so if I add a failing test, or if I add something and it breaks, no one will know because it will be the failing test number 101 out of when there are already 100 failing tests. So you may need to do some cleanup. Whatever your next step is, I would like to know. So go here. I'm around. I'm passionate about this stuff. Thank you very much for your attention. We're out of time.